Hello everyone, welcome back to our lesson 1 preview. So this week will be our first lesson. Please remember to go back to your classroom, all right? So there are two ways of calculating radicals. So this week's topic is all about radicals and real numbers, all right? So square root a times square root b equals to square root a times b. Maybe square root 2 times square root 7 equals to square root 14, right? So you all know that. And there is another way of calculating radicals. It's called quotient property. So maybe give you an example. Square root 18 over square root 2. It can be square root 18 over 2, right? Equal to square root 9 equals to 3, okay? So these two rules are very simple, and I think you can all remember. But there are two other types of equations or formula that are usually used in the calculation of radicals. Okay, so for this one, how to calculate? So let's take a little bit review. What is the perfect square? Perfect square: a plus b square equals to a square plus 2ab plus b square, okay? Or a minus b square equals to a square minus 2ab and plus b square, okay? And there is another type called difference of squares. A square minus b square equals to a plus b times a minus b, all right? So the questions talked in the preview video are all questions from Huaxiabei, okay? So because I know you are preparing for this kind of competition, so I especially prepared this preview for you guys. So how to make use of these formula into the solving of complicated radicals. So for the first part, let's see. This one equals to 9 plus 2 square root 4 times 5, right? And plus 1 over 2 plus square root 5. So further, you can write it as 9 plus 2 times 2 times square root 5. Okay? So 2 square root 5 and 9, what are their relationship? 9, you know that equals to 4 plus 5, right? 4 equals to the square root of 2, right? And 5 equals to the square root of square root 5. Okay? Then we know how to write it. So we can directly write it as 4 plus 2 times 2 square root 5 plus 5, right? And then plus, so maybe I will switch the order, square root 5 plus 2. And then in the next step, you will know why, okay? And further, because this one, you know that it's 2 square plus 2 times 2 square root 5 plus square root 5 square. So it is linked to the perfect square here, okay? So actually, you now know this part equals to square root 2 plus square root 5 square, okay? And the other part, because now the denominator has the radical here, right? So how to rationalize the denominator? So for both the numerator and the denominator, we can multiply a square root 5 minus 2, okay? Then square root 5 minus 2. So it actually equals to the original one, but the denominator will become square root 5 square and minus 2 square, all right? Because it's making use of the difference of squares, something like that. So the numerator is square root 5 minus 2, okay? So further, it equals to 2 plus square root 5 plus, so the denominator here, 5 square minus 2 square equals to 1. So square root 5 minus 2. So this one equals to 2 square root 5, all right? So actually the calculations are not that complicated. So let's look at this question. A and B are greater than or equals to 3. And we want to find the minimum possible value of this part. So because a is greater than or equals to 3, for this part, a minus 3 is greater than or equals to 0. So square root a minus 3 should be greater than or equals to 0. Okay, so this part, actually it's greater than or equals to 0. To make it the smallest, a equals to 3, square root a minus 3 equals to 0, right? So this part smallest value is 0. But for this part, we know that absolute value is greater than or equals to 0. So if we want to make it the smallest, so this part should be 0. So 3 minus square root b minus 3 should be 0. So b in this case should be 12, right? And then the smallest value of this one is 0. So 3 minus square root b minus 3 equals to 0. Okay? And then absolute value equals to 0. So the smallest value is just 0. Very easy, right? Or you can use the discussion that we taught previously, but it's not involved in some inequalities or equations, so don't worry about that. So let's look at this one. A and b are both positive integers, and square root 11 plus 4 square root 7 equals to square root a plus square root b. So sometimes maybe we can find some perfect squares in the square root, but this time, unfortunately, we cannot find any perfect squares, okay? So another way to solve this one is to the power of 2 for both sides. Okay, let's see what will happen. 11 plus 4 square root 7 equals to a plus b plus 2 square root a b, right? And then what can we find? Because a and b are both integers, so 11 a and b and 7 ab. So the coefficients here are different. So maybe we can further write it as 11 plus 2 square root 4 times 7 equals to a plus b plus 2 square root ab. So inside this part it is square root 28. All right. So now we know a plus b equals to 11, right? And ab equals to 28. So we can easily solve that, or maybe you can use the perfect square. A plus b square equals to 11 square equals to 1 to 1, right? So a square plus b square plus 2ab equals to 1 to 1. So a square plus b square plus 2 times 28 equals to 1 to 1. So a square plus b square is actually 1 to 1 minus 56. Okay, so this one equals to 65. Okay, so finished. Okay, let's look at this question. N is greater than 0. What are the results of n? So sometimes we can just make both sides to the power of 2, right? So for this part, it equals to 1625 plus n plus 1625 minus n, and minus 2 times square root 1625 minus n times 1625 plus n equals to 100, right? So n and n are cancelled with each other, so this part plus this part equals to 3250, right? And then minus 100 equals to 2 times square root 1625 square minus n square. So 3150 over 2 equals to square root 1625 square minus n square. Okay? So this part equals to 1575 equals to square root 1625 square minus n square. Okay? So 1575 square equals to 1625 square minus n square. N square equals to 1625 minus 1575 square equals to 1625 plus 1575, 1625 minus 1575. Okay? So n square equals to 160000. Okay? So n equals to 400 because n is greater than 0. All right? So finished. And then let's look at the last question. So how do you solve this one? 1 over 3 square root 2 plus 2 square root 3 plus 1 over 4 square root 3 plus 3 square root 4 plus 2 2022 square root 2021 blah blah. How to solve it? So a technique is called the splitting, right? I hope you all remember this one. So maybe let me give you an example. Maybe 1 over 2 plus 1 over 6 plus 1 over 12. Okay? How do you split it? So this one equals to 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4. Okay? Then maybe you can cancel these ones in the middle. This is called splitting. Okay? So the general term of the splitting is very important. So for this one, we can know that 1 over n times n plus 1 equals to 1 over n minus 1 over n plus 1. So we can do the splitting like this one. Okay? And then for this part, how can we find the term something like this? Maybe we can use the algebra. 1 over n plus 1 times square root n plus n times square root n plus 1, right? This one equals to 1 over square root n plus 1 times square root n and the square root n plus 1 plus square root n, right? Because you want to take out the common factors while doing some factorizations, right? So we can further simplify this one. So this one equals to 1 over square root n plus 1 times square root n, and then square root n plus 1 plus square root n, and then square root n plus 1 minus square root n. Okay? So the numerator becomes square root n plus 1 minus square root n. Okay? So this one equals to square root n plus 1 minus square root n over square root n plus 1 times square root n, and then n plus 1 minus n, right? The difference of square. So this one equals to square root n plus 1 minus square root n over square root n plus 1 times square root n equals to square root n plus 1 over square root n plus 1 times square root n minus square root n over square root n plus 1 times square root n. Okay? So this one and this one cancel, this one and this one cancelled is equals to 1 over square root n minus 1 over square root n plus 1. So the splitting of radicals are usually based on this concept, right? So let us remember this one and let's clear it. So this one equals to 1 over square root 2, right? And then minus 1 over square root 3, right? Plus 1 over square root 3 minus 1 over square root 4 dot dot dot, right? And then so plus 1 over square root 2021 minus 1 over square root 2022, right? So all the items in the middle are cancelled, so which will lead us to square root 1 over square root 2 minus 1 over square root 2022. So this one equals to square root 2022 minus square root 2 and 2 square root 1011. Okay? And then we can further simplify it. So we can times square root 1011. So 2 times 1011 and then 1011 square root 2 minus square root 2022. Okay? Which equals to 2022 1011 square root 2 minus square root 2022. So this is the end of our preview video today. So I hope these questions will help you understand some basic rules of calculating radicals. Okay? Hope you have a good time.